Unit 3, Section 3, Arithmetic Sequence. Session Objectives. By the end of this session, the student will be able to 1. Identify an arithmetic progression, and 2. Find the terms of an arithmetic progression. Meaning of an arithmetic sequence. An arithmetic sequence or progression is a sequence obtained by adding a constant number to a preceding term to obtain the subsequent term. Like if the first term is A, then to obtain the second term, we add a constant D to the A to obtain the second term as A plus D. To obtain the third term, we add D to A plus D, and that gives A plus 2D. To obtain the fourth term, we add that constant D to A plus 2D. That gives A plus 3D. To obtain the fifth term, we add that constant D to the fourth term, which is A plus 3D plus D, and that gives A plus 4D, etc. The first number, A, is what is called the first term, and D, the common difference. The general term or the nth term of any arithmetic progression or sequence is A subscript n is equal to A plus n into braces n minus 1 multiplying D. The number D is called a common difference because any two consecutive terms of an arithmetic sequence differs by the D. So, for instance, if we are giving A and we are giving D, and A is 2, D is 3, then we can form a sequence knowing that the first term is 2, then we write down the first term. Now the constant term that we shall be adding is given to be 3. So 2 plus 3 gives 5. That is our second term. 5 plus 3 gives 8. That is our third term. And 8 plus 3 gives 11. That is our fourth term up to infinity. Now, the nth term of the sequence above is A subscript n is equal to the first term A, which is 2, plus the common difference D, which is multiplying into braces n minus 1. Now, when we consider another arithmetic sequence, 9, 4, negative 1, negative 6, negative 11 up to infinity, then we can obtain our common difference D by subtracting either the first term from the second term, that will be 4 minus 9, which gives negative 5, or the second term from the third term, that will be negative 1 minus 4, which is negative 5, or the third term from the fourth term, which is negative 6 minus 1, which gives negative 6 plus 1, and that gives negative 5. Now we can find the general term or the nth term of this sequence, knowing our common difference in the first term. So the nth term, A subscript n equals the first term, which is 9 minus the common difference, negative 5 multiplying into braces n minus 1. Finding the nth term of an arithmetic sequence. Example 1. Find the common difference, the nth term, and the 300th term of the arithmetic sequence 13, 7, 1, negative 5 up to infinity. Now, since the first term is 13, and we have A to be 13. The common difference is given by D is equal to the second term minus first term, that is 7 minus 13, which is -6, or the third term minus the second term, which is 1 minus 7, which is -6, or the fourth term minus the third term, which is -5 minus 1, which is -6. Now that we know our first term and the common difference, then we can obtain the nth term. If the nth term is A subscript n is equal to A plus into braces n minus 1 d, then in place of A, we write 13, that is the first term, then plus the common difference, which is -6, then into braces n minus 1. Now, A subscript n is equal to 13 minus 6 into bracket n minus 1, because positive multiplying negative gives negative. Now, to find the 300th term, meaning our n is given to be 300. So A subscript 300 equals 13 minus 6 into bracket 300 minus 1, which gives 300 minus 1 times -6, then plus 13, and that gives -1781. That is -1781 as our 300th term. Finding the nth term of an arithmetic sequence. Example 2. The 11th term of an arithmetic sequence is 52, and the 19th term is 92. We have to find the 1000th term. To find the 1000th term, we need to know our first term and the common difference D. Now, we know the general term of an arithmetic sequence to be A subscript n equals A plus into braces n minus 1 multiplying D. Now, from the question, we are given the 11th term to be 52. But again, in the general formula or the nth term, our 11th term, A subscript 11 equals A plus into braces 11 minus 1 multiplying D. It means wherever there is n, we replace it with 11. So simplifying further, our 11th term, A subscript 11, gives A plus 10D. And the 19th term equals A plus into braces 19 minus 1 multiplying D. Again, wherever there is n, we replace it with 19. So hence, our 19th term equals A plus 18D. But in the question, we are giving the 11th term to be 52 and the 19th term to be 92. So in place of A subscript 11, we write 52. So that gives us 52 equals A plus 10D as equation 1. And 92 equals A plus 18D as equation 2. Now these two equations can be solved by using 4 methods or approaches, namely the substitution approach, the elimination approach, the graphical method, and the matrix approach. But however, we limit ourselves to 2 of them, that is elimination and substitution. But we look at substitution first. So we make A the subject in equation 1. By making A the subject, we subtract 10D from both sides. So if 10D is subtracted from both sides, then we have 52 minus 10D is equal to A. And we label that as equation 3. Now, we substitute this equation 3 into equation 2. It means in equation 2, where there is A, we write 52 minus 10D. And that gives 92 equals 52 minus 10D plus 18D. Now, subtracting 52 from both sides, this gives 40 equals 8D, because negative 10D plus 18D is 8D. Now, we want to make the common difference D the subject by dividing through by 8. So if we divide through by 8, our D is equal to 5. That is 40 divided by 8 is equal to 5. Now that we know our common difference D to be 5, now we put this D is equal to 5 into equation 3. And that gives A is equal to 52 minus 10 multiplying 5. Now if you multiply 10 by 5, that is 50. If that is taken from 52, we have A is equal to 2. And that gives A is equal to 2 as the first term, D is equal to 5 as the common difference. And hence, the general formula or the nth term is given as A subscript n is equal to 2 plus 5 into braces n minus 1. So to find the 100th or the 1000th term, wherever there is n, we put 1000. So A subscript 1000 is equal to 2 plus 5 into braces 1000 minus 1, which gives 4,997. Alternatively, the two equations can be solved by using the elimination method. Now, looking at the two equations, it is easier to eliminate A because they have the same coefficients and they are equal. That is 1, 1. So therefore, A can be eliminated by subtracting equation 1 from equation 2. So if you subtract 52 from 92, that gives 40, which is equal to A minus A will be 0. Then we take 10D from 18D, that is 8D. So it means our 40 equals 8D. Then we divide through by 8, and that gives D is equal to 5. Then we can find A by putting that 5 either into equation 1 or into equation 2. So when you put it into equation 1, that gives 52 equals A plus 10 times 5, which is 50. Then subtracting 50 from both sides, A equals 52 minus 50, which is equal to 2. And that can equally give us our first term and our common difference. Sum of first n terms of an arithmetic sequence. For an arithmetic sequence given by A subscript n is equal to A plus into braces n minus 1 multiplying D. For us to find the sum of terms given by that sequence, we let S subscript n to be the sum of n terms of that sequence, so that S subscript n is equal to the first term A plus the second term A plus D plus the third term A plus 2D plus the fourth term A plus 3D plus dot 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 plus the last term A plus n minus 1D. Now the order of this summation can be reversed, so that our summation S subscript n is equal to the last term A subscript n plus dot 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 plus A plus 3D plus A plus 2D plus A plus D plus A. Now if these two summations are added, then this gives 2S subscript n, which is equal to A subscript n plus A subscript n plus A subscript n plus dot 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 plus A subscript n. And since we don't know the number of terms in this summation, we add by multiplying n by A plus A subscript n, so that we have 2S subscript n is equal to n into braces A plus A subscript n. Now to find S subscript n, we divide both sides by 2, so that S subscript n is equal to n into braces A plus A subscript n divided by 2. Now, but we know our A subscript n is the same as A plus into braces n minus 1D. So replacing the last term A subscript n by that gives A plus into braces n minus 1D. Now A plus A gives 2A, then plus n minus 1 into braces then D. So that is why the first formula is S subscript n is equal to n over 2, then into square bracket 2A plus into braces n minus 1D. And the second one is S subscript n is equal to n multiplying into braces A plus A subscript n all over 2. And the second one is used if the last term, that is A subscript n, is known. Finding the sum of an arithmetic sequence. Example 1. Find the sum of the first 50 odd numbers. Now, for us to find the sum of the first 50 odd numbers, we have to find the sequence formed by these odd numbers. And that is 1, 3, 5, 7, 9, 11, dot, 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 that is up to infinity. From that sequence, we know the first term A is 1, and the common difference D is 2. That is, we either subtract the first term 1 from the second term 3, which gives 2, or the second term 3 from the third term 5, which also gives 2. Now, the nth term is given by A subscript n is equal to A plus into braces n minus 1D. Since we know our A to be 1 and D to be 2, we substitute them into the nth term, and that gives A subscript n is equal to 1 plus 2 into braces n minus 1. Now, expanding and removing the brackets, we have the nth term A subscript n is equal to 2n minus 1. So for us to find the 50th odd number, Then we substitute 50 in place of n, so that a subscript 50 is equal to 2 multiplying 50 minus 1, which gives 100 minus 1, which is equal to 99. So we now know our 50th odd number, which is 99, and we know the first odd number, which is 1. So hence we use the formula a subscript n is equal to n into braces a plus a subscript n all over 2. Since we know n to be 50, that is, we are finding the sum of 50 odd numbers. Then we have s subscript 50 is equal to 50 into braces a plus a subscript 50 all over 2. But our a is 1, a subscript 50 is 99. So we have 50 into braces 1 plus 99 over 2. So 1 plus 99 is 100, divided by 2 gives 50. So 50 will multiply 50, which gives 2,500. Sum of an arithmetic sequence. Example 2. Find the sum of the following arithmetic progression: 3 plus 7 plus 11 plus 15 plus ... plus 159. Now, for us to find the sum of this sequence, we need to know the number of terms in the sequence. And to find the number of terms in this sequence, we use the nth term formula, which is a subscript n equals a plus into braces n minus 1d. But from the given sequence, we know our first term is a, which is 3. And the common difference is d, which is 4. Now, we know the a subscript nth term to be 159. So substituting this into the formula, we have 159 is equal to the first term, which is 3 plus the common difference 4 multiplying n minus 1, which implies we have 159 equals 3 plus 4n minus 4. That is if you remove the brackets. Now, when we simplify, we have 160 is equal to 4n. So to find n, we divide both sides by 4. So dividing 160 by 4 gives n is equal to 40. Now that we know n, which is the number of terms in the given sequence, and we know a, we know d, then we find the sum of the sequence by using s subscript n is equal to n over 2 into square bracket 2a plus into braces n minus 1d. Now our n is 40. So s subscript 40 equals 40 over 2 into square bracket 2 times the first term 3 plus the common difference 4 multiplying 40 minus 1, which is simplified to be 3,240. Alternatively, since the last term is known and the number of terms in the sequence is known, and we know the first term too, so we can use the formula s subscript n is equal to n multiplying into braces a plus a subscript n all over 2, so that the sum of terms here equals s subscript 40 equals 40 into brackets the first term 3 plus the last term 159 all over 2, which gives 40 into braces 562 divided by 2, in which is also simplified to give 3,240. Sum of an arithmetic sequence. Example 3. How many terms of the arithmetic sequence 5, 7, 9 up to infinity must be added to get 572? Now we want to find the number of terms of this sequence that will be added to get 572. What it means is that we are giving the sum S subscript n to be 572. But from the given sequence, we know the first term to be 5, that is A is equal to 5. And the common difference, that is 7 minus 5 or 9 minus 7, that should give us D is equal to 2. Now, putting or substituting S subscript n, A, and D into the summation formula, S subscript n equals n over 2 into square bracket 2a plus into braces n minus 1d, we have 572 equals n over 2 into square bracket 2 multiplying 5, that is the first term, plus into braces n minus 1 multiplying the common difference 2. Now when we distribute n over 2 over the square bracket, we have 572 equals 5n plus n into braces n minus 1. Now expanding and simplifying, we have n squared plus 4n minus 572 is equal to 0. Now this is a quadratic equation in n. So we have to find two factors of 572. So that when we multiply, we have 572. When we add, we have 4. And these factors are 26 and negative 22. So when we write 26 and negative 22 in terms of 4n, then we have n squared plus 26n minus 22n minus 572 is equal to 0. Now factorizing, we have n minus 22 multiplying n plus 26 is equal to 0. Equating each of the brackets to 0 gives n is equal to 22 or n equals negative 26. Or the other way of going about this quadratic equation is that we can use the general formula for solving quadratic equations, which is n is equal to negative b plus or minus, or under the square root sign, b squared minus 4ac all over 2a. Now, we have n to be 22 or negative 26. But we know the number of terms cannot be negative. Hence, we ignore the negative 26 and have n to be 22, meaning the number of terms that are added to obtain 572 are 22 terms. Sum of an arithmetic sequence. Example 4. The sum of n terms of two arithmetic progressions are in the ratio 9n plus 2 is to 2n plus 1. Find the ratio of their sixth term. Now, for us to find the ratio of their sixth term, we must know that we are given two different sequences. So to find the sum of the first sequence, we let A subscript 1 be the first term of the first sequence. And for the second sequence, we let A subscript 2 be the first term. Likewise, we let D subscript 1 be the common difference for the first sequence, and D subscript 2 being the common difference for the second sequence. But we know the sum of first n terms of a sequence is given by n over 2 into square brackets 2a plus n into braces minus 1 multiplying d. So for the first sequence, we have n over 2 into square brackets 2a subscript 1 plus into braces n minus 1, then multiplying the common difference d subscript 1. Also, for the second sequence, we have n over 2 into square brackets 2a subscript 2 plus into braces n minus 1, multiplying the common difference d2. Now, when we find the ratio of the first sequence to the second sequence, we have 2a subscript 1 plus into braces n minus 1 multiplying d subscript 1 divided by 2a subscript 2 plus into braces n minus 1 multiplying a subscript 2, which equals the ratio given in the question, 2 plus 9n over 2n plus 1, and that gives equation 1. Now the ratio of the systems of the sequence can be found in the next slide. Now the ratio of the system of the first sequence to the system of the second sequence is a subscript 1 plus 5 d subscript 1 divided by a subscript 2 plus 5 d subscript 2, which is equal to 2a subscript 1 plus 10 d subscript 1 divided by 2a subscript 2 plus 10 d subscript 2, which is simplified to be 2a subscript 1 plus into braces 11 minus 1 d subscript 1 divided by 2a subscript 2 plus into braces 11 minus 1 d subscript 2. Now comparing equation 1 from the previous slide and equation 2 here, we find that the ratio given in the question is 9 into braces 11, since our n now is 11, plus 2 divided by 2 times 11 plus 1, which gives 101 divided by 23.